Hi there. This is a re-recording of the first lecture of the course. It looks like Teams, or looks like I didn't use Teams correctly to save the video, so I only have like the first 3 minutes and the last 3 minutes of the actual lecture. So this is CISC220, System Level Programming. Who am I? I'm Dr. Burton Ma. My office is in Goodwin 754 for when we're back from COVID. Office hours are going to be virtual on Teams. This time may change, so I'll update the time and information on OnQ. If you need to email me, please include CISC220 in the subject line so I know what course you're in. I teach a lot of students, and it's very annoying to have to look up what course a student is in when they contact me by email. Because it's actually quite hard to find out which student is in which course. You do have some teaching assistants in the course. Their contact information and office hours will be posted on OnQ. And everything else you need to know about the course will also be on OnQ. Lectures until the after reading week will be on Teams. You should have received an invite to the Teams lectures. I'll also post links to the streams, to the Teams meetings on OnQ later today. Lectures will also be recorded so you can watch them afterwards. After reading week, if we're in a lecture that supports it, the lectures will be live streamed from the lecture hall rather than being on Teams. To do that, you'll have to log in. There's a web link that there's a link that you can open in your web browser. You have to authenticate with your Queen's user ID, but then you'll be able to watch the lecture as it actually happens. Those will also be recorded and posted on OnQ. There is no textbook that you need to purchase for this course. So the course is essentially Bash programming and C programming. So there's lots and lots of online material that you can, reference material that you can easily find with a web search. There is a set of course notes that you can find by clicking that link. They are written by Dr. David Lamb. The notes are a bit terse, so just reading the notes probably isn't sufficient for doing this course. The two books that I will be referring to, the library has both of them available to you online. So the first book is called The Linux Command Line, second edition. So that's basically the book we'll be using to learn about Bash programming. The second book is Effective C, which is it's not a textbook, it's a reference book that describes the C language from a more modern perspective than the classic C texts. They're both of the books are not textbooks. They're actually reference books, so they don't have any exercises or things like that. Okay, so the grading. This is probably how you will be evaluated in the course. So the first three assignments will cover Bash programming. The next three assignments will cover C programming. There will be a midterm online via OnQ. There will be an exam. I don't know if it's going to be online or in person. I'll let you know once we figure out whether or not we can actually have an in-person exam. My feeling is that it will end up being online. Assignments should be done individually and submitted on OnQ. I would like to post solutions 3 days after the assignment due date, but for that to happen, everybody has to actually submit their work no later than 3 days after the assignment due date. The late submission policy reflects that, so I would like to not accept assignments after 72 hours after the posted due date so that I can post solutions fairly quickly after the due date. You lose 10% of the total marks for the assignment for each 24-hour period that it's late, right? So if you submit it late by 1 day or less, you lose 10%. So that's 10% of the total mark. So if it's out of 100, you're now the most that you can get is 90. If you submit 2 days late, then you lose 20%. So that you'll be the most you get is 80, and then after 3 days, the most you get 70. Sorry, 3 days or between 2 and 3 days late, it's the most you can get 70%. If you have an academic accommodation where the accommodation says you can receive more than 3 days of accommodation, then you'll have to contact me for alternate arrangements. Otherwise, what ends up happening is, so I can't post the solutions until everybody submits their work. So if you have an accommodation that's a week, that delays posting the solution for a week after the assignment is due, right? And the problem with that is that the answer to assignment 1 is often useful so that you can do assignment 2, right? And the answer for assignment 2 is useful so that you can do assignment 3, and so on. The midterm I already mentioned is going to be on OnQ during a regularly scheduled lecture hour. Obviously, there's no lecture on that day. The midterm will only cover Bash programming. The exam includes a very small amount of Bash programming and will be primarily C programming. Okay, so what's this course all about? So the calendar description is here, which I'm sure you can all read. Essentially, the course is about learning about an operating system called Linux. You're going to learn how to program in the Linux environment using the Bash shell, writing programs called Bash scripts, and then you'll be programming in C. The purpose of this course is to set you up for subsequent courses in the CS curriculum. So for example, many of your third and fourth year courses will require programming in either C or C++. Right. Okay, so what's an operating system? So a large part about this course is learning about, so one of the follow-up courses to this course is the third year operating systems course. So before you take that course, it's actually useful if you know a little bit something about operating systems. So an operating system, I'm sure you all have computers or at least used them. So most of you are either probably using Windows or Mac OS as your operating system. Some of you might be using Linux. The operating system is just software, but it's the software that sits between your computer hardware and whatever application it is that you're actually running. Right? So it's the software that lets applications access the facilities, the hardware facilities of your computer. So, for example, the operating system controls how applications access the CPU, things like the disk drive or the network, your USB interface. So how it accesses your keyboards and other peripherals and things like that. Most of you are used to working in a graphical user interface, right? So that's the way most users interact with an operating system. There is an alternative form of interaction, and that's to use what's called a command line interface. So a command line interface, which I can show you now. So this is an example of a command line interface. So this is Ubuntu Linux running in the Windows Linux subsystem. And so this is so there's an actual version of Ubuntu running. And this is how you can interact with the Linux operating system. Right? In a command line interface, you type commands into the command line. Right? So that's your command line. So for example, I can type in the command ls. So ls is the command that lists the contents of a directory. So I type ls and press enter. I can get a listing of all the files that are currently in the directory that I'm in. Most of this course involves using a command line interface to interact with a Linux operating system or a Linux-like operating system. All right, so what is this thing called GNU Linux? So if you click on that link there, it'll take you to a fairly high level description of what exactly Linux is. But in brief, GNU Linux is a free open source operating system. It's widely used on servers, mainframes, supercomputers, embedded devices. It's not very widely used on the desktop, although it can be used on the desktop. Right, the desktop operating systems are mostly Windows and Mac OS. The operating system is the Linux operating system is more properly referred to as GNU Linux, but most people just say Linux when they talk about the Linux operating system. In the next lecture, I'll explain why the operating system is called GNU Linux. So if we're going to be using Linux in this course, you need access to, well, a Linux operating system on your computer. Now, for our purposes, Mac OS is close enough. So if you have a Mac computer, there's not much you need to do. So one of the things you do need to do, though, is you need to get a text editor installed on your computer so that you can actually write some Bash and C code. Now, you probably want a text editor that is programming language aware. Right? There's lots of them on Mac. One of them that's free is Visual Studio Code. Right? If you click that link there, that'll take you to the download link. You can download the Mac version. There are instructions after you click the link that tell you how to install install it. Before we start programming in C, you're going to need to install the Xcode command line tools. If you click that link there, that'll take you to instructions on how to do that. The Xcode command line tools give you access to the command line interface for the compiler on your for the C compiler. For the C compiler in macOS. All right, if you're in Windows, you have a few options. So, I mean, one option if you have a Windows PC is that you can install Linux separately on your PC. So you can set up your system so that it dual boots. You can either boot into Windows or you can boot into Linux. That's a little more complicated than the option that's described here. So the option that's described here is to install what's called the Linux subsystem for Windows. And if you follow that link here, that will tell you how to do that. So that link actually tells you how to set up an entire programming environment in the Linux subsystem for Windows. So let me just go back here. So that this terminal that's open here, right? This is actually the terminal that's accessing the Windows subsystem, the Windows Linux subsystem. So this is what you'll get when you follow the instructions here. You'll also have instructions. If you follow that link, you can find out how to install the C compiler that we're using. You can also hit that link here, and that will tell you how to. That'll also tell you how to install the C compiler that we're using in this course. Either link, though, following either link will let you set up the Windows subsystem, though. The Windows Linux subsystem, sorry. Now, the other option is you can access CASLab remotely. My understanding is that CASLab is currently closed for in-person use, but you can always access it remotely. If you click that link there, that'll take you to instructions on how to access the lab. So you can either access it using SSH, and that will give you a terminal. That'll give you access via a terminal that looks like this. It's hard to write code in a terminal like this. You'll have to learn an editor like VI or Emacs. So you won't have a graphical editor if you do it that way. There's another way to access CASLab using a program called X2Go or something like that. I can't remember what its actual name is. If you follow that link, it'll take you there. That will give you a graphical interface. So it'll give you a access to the desktop on one of our servers um, uh, over the internet. I haven't had much luck using it, so I find it to be very slow. But you can try that out if you want a graphical interface to one of our Linux servers. All right, so that takes care of most of the administrative stuff for the course. Um, the next part of this lecture, I just want to show you how you can use the command line interface to do some, in this case, some silly stuff. Right. Uh, if you've installed the Windows Linux subsystem, before you try any of what I'm about to do, you'll have to run this command from the command line. So type sudo apt update and press enter. That will update your Linux installation. And then after you do that, you can install these pieces of software if you want to. You just type in the command. I'll show you how to do it. You type in the command. If it's not installed, it'll tell you how to install it. If you're on a Mac, it's harder to install most of these programs. So if you're on a Mac, just watch along for now. You can Google to find out how to do an internet search to figure out how to install these if you want to actually try these on your own computer. All right, so now the command line interface, right? So from a command line interface, everything that you do involves typing in a command and then pressing enter, right? And then the program in this terminal is called the shell, right? So the shell will will read what you type in and try to interpret it as a command, right? So one of the commands that you can type in is the ls command, right? So ls lists the contents of a directory, right? So when I type in ls, I find out that I've got all of these files inside the current directory or folder, if you want to think of it that way. Now, commands, to find out how to use a command, you can ask for help on the command in several different ways. One of the ways is to look at what's called the man page for the command. So most commands that you can access via the command line interface have a man page associated with them. So to access the manual or man page for a command, you just type man and then space and then the name of the command that you want to find information on, and you press enter, and you end up with in a program that shows you the contents of the manual. Right. So a large part about this course, a large part that you have to get used to in this course is reading these man pages. Right. So at the top, you can see here's the name of the command, ls, right? You get a short description of what the command does. So it lists the contents of a directory, right? It gives you a very brief synopsis of how to use the command, right? So apparently you type in ls. Then if you want to, you can type in some options, right? And then you can type in, if you want to, the name of one or more files, right? So anything in square brackets, that's an optional part of the command. Dot, dot, dot means you can type in one or more of these things, right? So I have one or more options. I can type in the names of one or more files if I want to. Right. The options are described here, right? I'm not going to take you through the options today. We'll learn about how to use these commands in later lectures, right? So I just want to show you right now that this is how you can find information about certain commands. Okay, so let's see. So commands. So there's ls. The command cal displays a calendar. So if you just type in cal with no options or other arguments, right, you get the calendar for the current month, and the current day is highlighted. Right. If we look for help on the cal command, right, we can see that there's lots of ways to use this program, right? Again, I'm not going to go through all of these right now, right? I just want to quickly scroll through and see that there's this option -y that will display the calendar for the specified year. Right. So if I type in cal -y, right, I can get a display of a calendar for the entire year. Right. And again, the current day is highlighted. Right. So there's the calendar for the year 2022. The date command, right? Not surprisingly, that prints out today's date and time. Right. So it tells me that today is Wednesday, January 12th. It's almost 11 o'clock Eastern Standard Time of the year 2022. Right. Again, you can type in man date to find out more information about the date command. But if I type in date -u, right, I can get the date in universal time. Right. So it's 1559 in universal time. All right. So what else is there? SL. All right. So the SL command. All right. So LS is probably one of the most common commands that you use when you're working on a command line interface. Right. So a lot of working on the command line involves moving between directories on your computer. When you move to a directory, often you want to know what's in the directory, right? So you type in ls to find out what's in the directory, and it turns out that you do this a lot, right? Now it's easy to type in SL instead of typing in ls, right? Now normally if you type in SL, you'll get an error, right? So if you type in a command that your shell can't interpret, so let me make something up like that, right? It'll tell you that the command is not found. Right. So normally if you type in SL instead of ls, you'll get SL, command not found. Now because it's so common to make this mistake, some programmer with some free time on their hands decided to make a program called SL. SL is short for steam locomotive. So all it does is it makes a steam locomotive run across your screen. All right, if I look at the man page for SL, right, it tells me that, right, it tells me what the purpose of the program is, right? Display animations aimed to correct users who accidentally entered SL instead of LS, right? You can see it also has some options. So for example, you can make the locomotive fly by typing in -F as your option, right? So SL -F, and your locomotive now flies across the screen. All right, fortune. So fortune is a command that prints a random fortune to the screen. Right. So here I get you are fighting for survival in your own sweet and gentle way. If I type in it again, I get a different random fortune. Right. So fortune prints a random, hopefully interesting adage. Right. So somewhere on this computer there are one or more files that contain basically lists of fortunes or sayings or adages, whatever you want to call them, right? And so it tells you, if you read the description, that when it's run with no arguments, it prints out a random epigram, and it tells you the epigrams are divided into several categories. Each category is subdivided, and so on and so on and so on, right? And you can, again, there's lots of ways that you can run this program. Cowsay. Okay, so cowsay. Now, when you run a program or a command, right, often what you need to do is you need to provide the command with some information. So cowsay is one of these programs. So cowsay is a program that will print a cow that displays whatever message whatever message you tell it to. So for example, I can do cowsay hello, and that will print a cow that says that prints out a hello in a bubble up here. Right? If you look at the man page for cowsay, right, you can see that there's this option -L. Right, -L. If you actually read through all the documentation, where does it go? here it is. It tells you that it will, if you call calsay with the -L option, it will list all the cal files on the current path. So let me try that. Calsay -L. Right. And so it tells you that in this directory, there's a bunch of files. And these are the list of files. Right. So these are all of the shapes that you can replace the cal with. Right. So for example, I can write calsay -F. I can do koala. I can do hello. And now it prints a koala bear saying hello. Right. Okay, so calsay is an example of a program that takes some input, right? So it reads what's called, it takes the command line argument, and it uses that, and it prints that argument, right? So the neat thing about Linux commands is that you can take the output of one command and feed it to the input of another command, right? So remember fortune, right? So fortune is a command that prints some random fortune, right? So I can take fortune, or I can take the output of fortune, so the horizontal bar, and I can redirect that to the calsay program, right? So what these two commands do is that fortune prints a command, right? Instead of printing it though, it'll redirect the command to the calsay program, right? So the calsay program will take the output of fortune, and then it will use whatever string fortune generates to print, and it'll print that string using the calsay program. So if I do, I think this works, right? So I can take the output of fortune, I can send it to calsay, and I can tell calsay to use Hello Kitty to display the message, right? So here, the output from fortune was this. You're currently going through a difficult transition period called life, right? Passes that string to calsay. Calsay prints the string using using the image defined in that file there. Now, you can make very complicated, so you can make quite complicated commands by chaining together multiple commands, right? So you can do, you can achieve very powerful effects by using, by using several different commands to do something and passing the output of one command to the next command. Toile. Toile is another program that prints something, that prints the string that you tell it to, right? Except this time it uses ASCII art to print the message, right? So just like calsay, you can take the output of one program, like fortune, and send it to the input of the Toile program, right? So here, what's our fortune? Don't worry so loud, your roommate can't think, right? And you can do this for any command that prints something. So I can take date and send it to Toile, right? And that'll print out the date using this ASCII art font, right? And you can do the same thing with calsay, right? So, oops, date, sorry, calsay, like that. All right, now the last command is just for fun, right? So the C matrix program, well, it does the following, right? So let's see what the man page for C matrix says. Simulates the display from the matrix, right? All right, so as the course progresses, we're going to learn more about Linux commands. So I'm going to show you, I don't know how many commands you'll learn about before we finish, before we get to C programming. There's literally thousands of different commands that are probably available to you on your system. Obviously, we're not going to go through all of them. We're going to try to look at the some of the more important ones, but that'll be the topic of the future lectures.